Ever wondered what would have happened if things went a little differently?
Like if a major historical event had never happened.
Exactly. Well, today we're going to dive into a method that lets us explore those what ifs. It's called synthetic control.
And it's like having a time machine for data. We can rewind history and create alternate realities to see how things might have turned out.
This seems kind of sci-fi, but it's actually a powerful tool used in economics and other fields.
We'll be looking at a study that used this method to analyze the impact of German reunification on West Germany's economy back in 1990.
Yeah, it's a fascinating case study because it tackles a fundamental challenge. How do you isolate the effects of a unique event like reunification when you can't just rewind history?
Right, it's not like we can just compare West Germany to, say, France.
Yeah.
They were on totally different paths even before reunification.
So how do you create a valid comparison?
That's where traditional methods like difference in differences or DD can fall short.
Dictate.
Yeah, it essentially compares trends before and after an event, but it relies on finding truly comparable control groups.
Which is nearly impossible in a case like this.
Yeah, exactly.
So we hit a dead end with Diddy pretty quickly, but thankfully the researchers had this secret weapon up their sleeve, synthetic control.
Ah, yes. This is where it gets interesting.
So tell me about this synthetic control. How does it work?
Think of it like building a what-if scenario specifically for West Germany. Instead of relying on other countries as imperfect comparisons, we actually construct a synthetic version of West Germany using a clever combination of data from other countries.
So it's like we're Frankensteining together the perfect economic doppelganger.
Uh-huh. Yeah, in a way, yes. We create this synthetic twin by taking a weighted average of economic data from a pool of other countries.
Okay, so it's not a one-to-one comparison with a single country. It's more like a custom blend.
Exactly.
So how do we decide which countries to include and how much each one contributes? Is it like a recipe?
That's where the magic happens. The synth package in R helps us sift through a ton of data and calculate the optimal weights for each country in our donor pool. We feed it a bunch of economic indicators like per capita GDP, trade, openness, and investment rate to make sure our synthetic twin is a close match for the real deal before reunification.
So it's all about finding countries with similar economic DNA.
You got it.
So what was the recipe for our synthetic West Germany? What countries went into the mix?
Well, the analysis revealed that the optimal mix included a hefty 39% Austria, 17.9% Switzerland, and surprisingly even 16.9% USA.
The USA. Now that's interesting. I wouldn't have guessed they'd be a major ingredient in our synthetic West Germany.
It's fascinating how the model naturally gives higher weight to countries that are geographically and economically similar to West Germany. It reinforces the idea that even in economics, similarities matter.
Okay, so we've got our synthetic twin. Now what? What do we do with it?
Now we get to the heart of the matter. Comparing the real West Germany's economic performance after reunification to that of its synthetic counterpart.
Okay, so we let them both live out their economic lives after 1990 and see what happens.
Precisely.
And what did they find? Did reunification give West Germany an economic boost or hold it back? I'm on the edge of my seat here.
Well, when you plot the GDP trends of both the real and synthetic West Germany's, you see them start to diverge after 1990. The real West Germany's GDP actually lags behind the synthetic version, suggesting that reunification had a negative impact.
That's unexpected. I would have thought reunification would have led to a stronger economy.
It's a complex issue with lots of factors at play. But the synthetic control analysis provides some compelling evidence to suggest that reunification did come at an economic cost for West Germany.
Interesting. But wait, how do we know this isn't just some random blip? How do we know this negative gap is really because of reunification and not just chance?
That's a great question and one of the trickier aspects of synthetic control. Unlike traditional methods, we don't have straightforward standard errors or p-values to tell us how confident we can be in the results.
So how do we test the validity of our findings if we don't have those usual statistical tools? Do we just have to trust the model?
We use something called placebo tests. Imagine we pretend that each country in our donor pool also experienced a reunification in 1990, even though they didn't. We then create synthetic versions for all of them and see what happens to their GDP trends.
So it's like running a bunch of alternate realities to see if our original finding holds up.
Precisely. If our method is solid, these placebo effects should be small and random. But if the negative gap for West Germany stands out as unusually large compared to these placebos, then we have more confidence that it's a real impact, not just a statistical fluke.
Okay, so it's like a stress test for our findings. We're seeing if they can withstand some serious scrutiny.
Exactly.
And did the researchers find that West Germany's negative gap was unusual? Did it pass the placebo test?
When they ran the placebo tests, they did find that some of the placebo gaps were large, but West Germany's was still among the more extreme ones. It wasn't a slam dunk, but it definitely strengthened the case.
Hmm. So it's starting to look like reunification really did have a negative impact, but it sounds like there's still some room for doubt.
Right, and that's why the researchers went a step further and introduced something called root mean squared prediction error, or RMSPE.
Okay, I'm going to need you to break that down for me. What exactly is RMSPE and why is it important? It sounds pretty technical.
Think of RMSPE like a score for how well our synthetic West Germany matches the real one before reunification. The lower the score, the better the match, and the more confident we can be in the findings.
So it's like saying if you can't predict the past accurately, how can you trust your predictions about the future?
Precisely. RMSPE helps us filter out those placebo results that are based on a shaky foundation.
Okay, that makes sense. We want to make sure our synthetic control is built on solid ground. So they reran the analysis, taking RMSPE into account. What happened? Did it change the outcome? Did it make the negative gap for West Germany look even worse?
It did. After accounting for RMSPE and removing those poorly fitting placebo countries, West Germany's negative GDP gap looked even more significant. Initially, the p-value was 0.353, which isn't very strong, but after the RMSPE adjustment, it improved to zero point 0.1.
Okay, so it's still not ironclad proof, but it's definitely far more compelling than what we got from the initial Demerity analysis. It sounds like synthetic control really is a powerful tool. But before we get carried away with the possibilities, let's talk about the practicalities. When wouldn't you want to use this method? What are some of its limitations?
That's a great question, and we'll delve into all of that and more when we come back in part 2 of our deep dive.
Welcome back. We were just talking about the power of synthetic control, but now I'm curious about the flip side. When is it not the right tool for the job? What are some of the limitations we need to keep in mind?
So one of the key requirements for synthetic control is you need a clear treatment event that happens at a specific point in time, like a light switch being flipped on or off. If the phenomenon you're studying is more gradual or diffuse, synthetic control might not be the best approach.
So something like the impact of climate change on a region wouldn't be a good fit.
Exactly. You wouldn't have that sharp before and after distinction that synthetic control relies on.
Okay, that makes sense. What about the data itself? Are there any specific data requirements?
Absolutely. You need a robust data set with reliable information for both the treated unit, the one experiencing the event, and the potential donor pool.
Those other countries we use to build the synthetic twin.
Right. And the more similar those donor units are to the treated unit, the better. It's all about finding those economic doppelgangers.
I like that analogy. So finding good matches is crucial.
And if the data is sparse, inconsistent, or full of gaps, you're going to have a hard time constructing a reliable synthetic twin. Garbage in, garbage out, as they say.
So data quality is key. What about the analysis itself? We talked about how that synth package in R does a lot of the heavy lifting, but is this method computationally intensive? Could that be a barrier for researchers?
It can be, yeah. Calculating those optimal weights for the synthetic control can get pretty complex, especially with a large donor pool or a long time series. And the placebo tests also add to the computational burden.
So you might need some serious computing power, especially if you're running a lot of those alternate reality simulations. But thankfully, as computing power becomes more accessible and software packages continue to evolve, this barrier is becoming less and less of an issue.
That's right. But even with the best data and software, interpreting the results of a synthetic control analysis requires careful thought and judgment. It's not just about plugging numbers into a formula.
You really need to understand the context of the event you're studying, the characteristics of the donor pool, and the potential limitations of the method itself.
Absolutely. Transparency and replicability are key for building trust in any scientific method, especially one as relatively new and complex as synthetic control.
Speaking of trust, I know there's been some pushback from economists who aren't quite ready to fully embrace this method. What are some of the common criticisms? What are the skeptics saying?
Some of the concerns revolve around the lack of those traditional statistical tools we're used to, like p-values and confidence intervals. It can make it harder to quantify the uncertainty in the estimates.
Right. But we talked about how synthetic control uses those placebo tests as a way to assess the robustness of the findings.
Exactly. While placebo tests don't provide the same level of statistical rigor as traditional hypothesis testing, they offer a valuable way to gauge whether the observed effect is truly unusual or just a product of random variation.
So it's not a perfect substitute, but it helps address some of the concerns about uncertainty. What other criticisms have you heard?
Another criticism is that synthetic control relies heavily on case studies, which can limit its generalizability. Because it's designed to study the impact of a specific event on a single unit, it can be challenging to extrapolate those findings to other contexts.
So we need to be careful about overgeneralizing. Just because it worked for Germany doesn't mean it'll work everywhere.
Exactly. But even if we can't make sweeping generalizations, carefully designed case studies can still provide valuable insights. They can help us understand how a particular intervention or event played out in a specific context, and that knowledge can be applied to other situations, even if we can't directly extrapolate the findings.
So context matters. What about the potential for subjectivity in the analysis? We've talked about how the researcher has to make choices about things like the donor pool and the predictors. Could that bias the results?
It's a valid concern, but there are ways to mitigate this risk.
Like being transparent about your choices and justifying your decisions, and running different specifications to see if the findings hold up.
Exactly. Transparency and robustness checks are essential for addressing concerns about subjectivity and building confidence in the results.
So it sounds like synthetic control isn't a foolproof method. It has its limitations and requires careful interpretation, but it also has the potential to revolutionize the way we study certain types of questions.
It's all about choosing the right tool for the job, understanding its nuances, and using it responsibly.
And staying curious and open to the possibilities. Synthetic control is a relatively young method, and it's still evolving. Who knows what exciting new applications we'll discover in the years to come?
That's the beauty of scientific progress. It's an ongoing journey of discovery. Who knows, maybe one day we'll be talking about synthetic control as a commonplace tool in fields far beyond economics. Imagine using it to study the impact of a new marketing campaign on a specific company, or the effectiveness of a public health intervention on a particular community.
Yeah, the potential is huge. Now that we've explored the ins and outs of synthetic control, let's shift gears a bit and see how it can be applied to a real-world scenario that's relevant to you, the ODU and EVMS merger.
Yes, you mentioned that earlier. Imagine using synthetic control to study its impact down the line. We could create a synthetic ODU using data from other universities and see how things play out compared to the real merged institution.
It's like having a data-driven crystal ball for higher education. Instead of just speculating about the merger's effects, we could use synthetic control to generate evidence-based insights.
Exactly. We could compare things like enrollment trends and graduation rates and even research funding between the real ODU and our synthetic counterpart.
It'd be fascinating to see if the merger leads to a positive or negative divergence. So how would we actually go about setting up a synthetic control analysis for this merger? And I'm really curious to see how this would work in practice.
Well, we'll dive into that in just a moment. First, a quick message from our sponsors.
All right, we're back and ready to tackle this ODU-EVMS merger using the power of synthetic control. So where do we even begin? How do we set up this analysis?
Well, the first step is to pinpoint our treatment.
The merger itself, right?
Exactly. Which happened in, let's see, insert merger year.
Right.
Then we got to decide what we want to measure. What's the outcome we're interested in? Enrollment, graduation rates, research funding.
Let's focus on research. Let's say we want to see if the merger boosted or busted ODU's research funding.
Perfect. So our outcome variable would be ODU's total research expenditures each year. Now comes the fun part, building our donor pool.
Finding those other universities that are like ODU's long-lost siblings.
Haha, exactly. We want to create a synthetic ODU that shows us what might have happened if the merger never went down.
So we're looking for universities that resemble ODU but haven't gone through a similar merger.
You got it. We'd gather data on their research spending over time and let the synth package work its magic.
Finding those optimal weights to create our synthetic ODU, a parallel universe ODU where the merger never happened.
Precisely. And once we have that, we can compare its research expenditures to the real ODU's expenditures after the merger.
And if there's a big difference, that suggests the merger had a real impact.
Exactly. But to be extra sure, that difference isn't just random noise. We got to run those placebo tests. Remember those?
Oh, yeah, those alternate realities where we pretend other universities also merged, even though they didn't.
Right. We see how their research spending changes and compare it to ODU's. If ODU's change is way different from those placebo universities, it strengthens our case.
So it's like saying, hey, this ODU EVMS thing really stands out. It's not just business as usual.
Exactly. Now, of course, every real-world scenario has its quirks. What are some challenges we might hit when applying synthetic control to this particular merger?
Hmm. Well, finding a perfect donor pool could be tough. ODU and EVMS are pretty unique, so finding other universities that are mirror images might be tricky.
Good point. And if our donor pool isn't a good match, our synthetic ODU won't be accurate and our results will be shaky.
Right, it's all about finding those good doppelgangers. What else?
Well, the merger is still pretty recent. We might not have enough data yet to see the long-term effects. It's like trying to judge a book by its first few pages.
So patience is key. We might need to wait a bit longer before drawing any firm conclusions. But even with those challenges, it sounds like synthetic control gives us a solid framework for analyzing this merger.
Absolutely. It lets us move beyond speculation and generate real, evidence-based insights.
It's like trading in our crystal ball for a data-powered microscope.
Huh, I like that. And this brings us to a broader point. If synthetic control helps us understand the past, what about its potential for peeking into the future?
Oh, predicting the future. You mean using synthetic control to forecast what might happen? Like, what if we implemented this policy? What if we invested in that company?
Exactly. Imagine modeling the impact of a decision before you make it.
That's like having a superpower. But isn't predicting the future inherently impossible?
Of course, the future is always uncertain. But synthetic control, with its ability to isolate cause and effect and model counterfactuals, gives us a powerful new lens.
So it's not a crystal ball, but it can help us make smarter bets.
Right. And as data gets even bigger and we refine these methods, its predictive power will only grow. So what have we learned today? Synthetic control is a game changer for understanding complex questions. It's not just for economics. It's for anyone trying to tease out cause and effect. Whether you're studying history, making business decisions, or even just trying to understand the world around you, this method can offer powerful insights. So the next time you're wrestling with a what-if question, remember the power of synthetic control. It might just unlock the answer.
And on that note, we've reached the end of our deep dive. Thanks for joining us, and we hope you'll keep exploring with us.
Until next time.
Keep those what-if questions coming.